In this second video of the Analog Electronics lab, so we shall continue to see some more experiments. So let us again look back to the previous experiment what we saw in the first video. So this is to get a DC voltage of 7.7 volts. So we found that the value of this center tap transformer happens to be 606 and the capacitance value happens to be 1000 microfarad, which will give a load current of 23.89 milliampere and a ripple voltage of 238 millivolts and a DC voltage of 7.88. So we could able to get a voltage close to 7.7 and a ripple voltage of 200 millivolt. And we shall also see how does the load regulation of this particular circuit looks like. So we are supposed to do a load regulation, for which let us connect the value of RL such that it is varying. So let us vary the value of RL and increase the current. So let us try to note down what is the V0 value. So ideally V0 should remain constant whatever the load current is. As the value of RL reduces, so in the previous example we took the value of R to be 330 ohm. So let us start reducing the value of R from 330 ohm to maybe 300 ohm, 30, 200 ohm, 150 ohm, 100 ohm, so on so. So as we are reducing the value of R, naturally the current will increase. So output has to slightly reduce. So that's what this graph says. So this output voltage has to reduce considerably as the load current increases. The variation is very small when the load current is less. When the load current is more, the deviation from the ideal value is too much. Now this is how we can do the load regulation for this particular experiment. And we shall try to see how do we design and demonstrate a circuit to obtain the characteristics which is shown here. So we are supposed to get a constant voltage of 3 volt when the input voltage is less than 3. The input voltage is more than 3 volts, so we are supposed to get the output voltage same as the input, that is a slope of 1. So for which the circuit diagram is given over here, and assuming a diode drop of 0.6, so we have to use a battery of 2.4 volts, so that 2.4 plus 0.6 happens to be, so it will be 3 volt here. So when diode is conducting, so I think the diode turns on only when the input voltage is more than 3 volts here. So when the diode is